Hi, I'm going to lay out the outline. We'll observe how throughout the construction of the fabric bucket, our group utilized the engineering design cycle. Next, we will go over our distinct strategy we used to think outside the box. Furthermore, we will see the complications we encountered during the entire testing and design process and how we tackled them. Lastly, we will conclude with the takeaways from this group project.
The engineering design cycle. It's not a motorcycle. The first thing we did was familiarize ourselves with the requirements for this particular challenge. We knew we had to create a fabric bucket that would hold at least 1 gallon of water for at least 1 minute without leaking. It also had to be a certain size. It needed to fold to fit into a 6-inch by 6-inch by 6-inch box. It also needed to be no greater when unfolded than 30 inches in height, including the handle. We also figured out how the project was scored, and we knew that if we had a high mass, that would come back to bite us in the end. We then moved on to researching how to waterproof fabrics in the first place, and we also researched the strengths of different fabrics, so this way we would know which ones would hold a gallon of water without tearing. We brainstormed ideas for the design, keeping in mind the unique aspects we wanted to include. We knew we wanted to have backpack straps of some kind so someone could wear it. We also knew we needed a strong material, but light, so this way it would hold the gallon of water, but also increase our score. We decided to go with a drawstring bag design, so this way the water would not spill out, and it could be carried easily on somebody's backs. This was very useful, because the more weight that was added into the bucket, the more the string would close, and less water would come out the top. We ended up testing a lot of fabrics, with 2 main waterproofing processes. We ended up selecting the best waterproofing process with the best waterproofing, with the best fabric. We ended up making a prototype bucket out of that, and we tested its strength and durability. We were then able to sew it into the final shape, and then we waterproofed the bucket to make the final design. We tested our final design and decided to repeat the waterproofing process one more time to make sure it was completely waterproof. Finally, we added some more designs onto our bucket to make it more presentable. We added paracord drawstrings, Tyvek handles. That gave us a multiplier, which we went for. In our research, we discovered that a lot of the teams didn't go for multipliers at all, so we made it our mission to try and hit as many as we could. We hit somewhere around 4.
We had to overcome several obstacles in order to complete the final design of our bucket. In the beginning, we had decided to use a solution of linseed oil and mineral spirits to waterproof our fabric because it was of natural materials. However, the water kept on leaking through the solution, even after testing it on 4 different fabrics. We had to change our method back to one of our original ideas of using a synthetic chemical. Another obstacle we faced was that the chemical coating would crack when we folded the fabric to fit in a 6 by 6 inch container. So to overcome this, we added another coat of the chemical to patch up any cracks. We also struggled a lot with actually using sewing machines to make our prototype and final bucket. None of us had used a sewing machine before, so it took a lot of patience to learn. Many different variables were introduced when we began sewing, including which thread would make the strongest seams, minimizing the holes created in the fabric by the needle, what was the strongest stitch, and what tension would work for the fabric.
What made our group, the Fickle Fabric of Fate, so special and unique? Well, I'm going to tell you. We came into this project focused on one thing and one thing only: to create a fabric bucket that could be used with real-world intentions. We didn't just want to complete the bare minimum and slap together some fabric and hope it held a gallon of water for a minute. We focused on how we could create a professional-looking, designed fabric bucket. When people would walk by our table, we wanted them to think we bought our bag at a store, which actually happened. Of course we wanted our bucket to succeed in the goal of holding a gallon of water for a minute, but we wanted to exceed that goal. To make our bucket unique, we folded the seams on the inside layer so the pressure of the water would be spread out over a larger surface area, relieving pressure from the corners. We also used 2 layers of our chemical-soaked fabric. To make our fabric bucket easily portable, we attached drawstrings to create a backpack, while also being able to close the bag when needed. In addition, we focused on the type of stitch and used a zigzag stitch for the outside layer to create a better design. Our finishing touches included Tyvek handles and an NCSU logo on the front to really sell our product. By keeping marketing in mind, we really ended up having a unique design and presentation during FED.
Hi, I'm going to tell you some of the key things that we learned while working on our fabric bucket. First of all, we learned that attention to detail is vital, especially considering that one weak spot in our bucket would have caused it to leak water. Therefore, we had to make sure all of our seams and coatings were done correctly. Secondly, we learned that there are many variables to consider, and it's not likely you'll arrive at the solution on your first try. So we learned to effectively utilize the engineering design cycle in order to arrive at our final solution. Additionally, some of our team members even learned how to sew. And lastly, hard work and good teamwork is essential. We spent countless hours working on our bucket, and in the end, this led us to victory.